Hello, good morning everyone. I'm Dr. Shashikant Dargar from Department of AC along with Dr. B. Perumal sir from the department. We are going to explain today about the antenna and propagation laboratory physically we are performing here, and we'll share this video with you all to understand the fundamental and enjoy learning. So today, first before starting the experiment, the first important thing we need to understand what are the components of the experiment in the lab which we do. You do using CST microwave simulation at design of some type of antenna, and then radiations and that what pattern it is coming. It is simulated based on the port which it is supplied to, right? It is solving the equations and electromagnetic equations, and it is giving you the electric field, and that gives you field pattern. Here in the lab, let me introduce this first. This one component which is the source of antenna, which is antenna trainer of the antenna trainer kit. We have antenna trainer RF generator here. So that RF generator is used for generating the RF signal. Actually, it is the source to provide the current to the antenna which we apply. Then we have a turntable. It means there are two must we use. This is the must. It is called a must. This must is used for keeping two antennas in the line of sight. The another one you can see other side is an antenna, another mast which is connected, and a planar type of antenna. These are the educational antennas which we have. So I would like to show you one by one educational antennas. Like for example, here you can see it is an antenna which is a planar type of antenna. If you closely look at this, there is a wire type of antenna which is having some diameter. In the CST Microwave Studio, we have designed a two half wave and quarter wave simple dipole. So this is a dipole antenna structure which is connected through this PCB. If you can closely look at this PCB connecting wires are there. So this is called as a feed line. So feed line is on a PCB from this wire. So similar type of this antenna for a particular, because you know the antennas are designed for a particular frequency. So particular range of frequency these design antennas are there. So this RF antenna will give the input to the antenna, and there is a turntable you can see here which is showing the different values of the input. We can say at every angle what are the radiations are there. So we used to rotate this and we check the radiation pattern in a 2D plot. It will be a 2-dimensional plot. And receiving antenna similarly is placed on another mast here, and we connect the antenna under test. As I told you in the last class also, and in our theory we have discussed that the receiving antenna that we can adjust very easily. So this is our transmitter side, doesn't mean it is transmitting the signal. Here we have a trainer, because you know it is not bulky, because antenna follows the reciprocity. So if you rotate this and take the plot of this, or if you rotate this and take this as a reference antenna, it is not going to be different. It follows the reciprocity. So with this, let me introduce the component once again. This is RF generator. You have this turntable at transmitter side connected here. You can see what are the functions in the RF generator available. You can see RF generator is internal block of this. It is similar type of function generator. There is a FS adjust, full scale adjust knob here. We take the output from this terminal, and suppose we are giving an external input. In that case, from this generator, in that case we can take the output from this. Power push button is there in this trainer. It is Scientec make 2261 RF trainer. Then similarly, this antenna which we have, we can adjust the height of this a little bit. Okay, and here it comes an important role of antenna which we say what should be the distance between these two. The distance between these two should be according to the far field. It means the diameter of this antenna. If you say highest dimension of this antenna is d, so 2d square by lambda, up to that distance we take the 2d square by lambda. If we make a radius here and we make a circle out of this, it should fall out of the circle. I think you are getting it. This is the maximum dimension of linear dimension of an antenna. Okay. If you take, you are using a frequency of suppose 1 gigahertz or 2 gigahertz. If you calculate, so it is it is an educational kit. Already this has been defined that how much should be the distance between the transmitter and receiver antenna. Okay. So with this, we will start our experiment of performing radiation pattern. But let me go before to this to receiver side. In the receiving type also we have the signal. You can see very interesting part that there is a signal which is applied to transmitter. There is nothing in between this, right? This is only a adapter which is connected for this RF detector. It detects the current received by this antenna. If I remove this antenna, you will find the RF detector shows 0. There is nothing radiated, nothing received from this, right? And once I connect this structure, you can see it is received. Isn't it magical? You can see it is the first time prediction of the RF electromagnetic signal. We are transmitting through this, we are receiving the signal from this, and then we are observing the amount of, it is detector, RF detector. So it will receive the current. At the end point of these two antenna, okay, the maximum current density used to be there, and that radiation patterns are received by this and shown by this RF meter. This is a milliampere meter which shows for the low frequency. Is that clear to everyone? With this, let me go ahead with the experimental part of this, how we align it, how to align RF antenna. Let me introduce the different types of antenna. It will be interesting to know. First of all, if we talk about the wire type of antenna, the wire antenna, so we have dipole antennas, and dipole antennas may be a quarter wavelength antenna, it may be half wavelength antenna, as we have also designed the CST microwave, CST studio in a student version which we use to understand how to design an antenna there. Here you can see it's a dipole, so the length of this, total length of this is lambda by 2. Total length of this is lambda by 2. Can you see this? So this part is lambda by 2 and this part is lambda by 2. So this is the wire which is used, and diameter here we can measure it, otherwise it's already mentioned in the manual. So with that diameter we designed actually this particular part, and here in the physical lab today we are going to verify its pattern, that how the signal is received. For this we need to align, because you know antenna receives the power which is normalized field or normalized power pattern. Here we are calculating, we are taking the current received from this antenna. So let's say we have used an antenna here. From this you can adjust the gain. What is the purpose? That we want first of all to, when it is in the line of sight, it should receive the maximum signal. So let me use two dipole antennas. So several type of antennas I would like to show you. Excuse me. This one antenna which you are looking at this, you can see what is the difference between these two antenna is. The length of the wire. If you see these two antennas, the length of the wire is the difference. The length of this antenna is larger than, this is lambda by 2 and this is lambda by 4. So lambda by 4, because you know lambda is equal to C by F, we can calculate the value of lambda and we can know for what frequency it is operating. You can even measure it using the scale and you can calculate for what frequency range it is designed. It cannot be a uniform antenna designed for all signals. It's an educational antenna which is working on the frequency which is generated by this antenna generator. So using this quarter wave, this is quarter wavelength. I think this is the time to identify the antenna. It is quarter wavelength antenna. It is half wave wire antenna. Okay. It is called as a dipole antenna. It is a dipole antenna, not this particular part, this particular portion only, where we can say this antenna is designed and it is molded. There is a lambda by 2 distance here, lambda by 2 distance here. In between this, there is a transmission of this. In theory, we'll discuss about this, why it is molded and what is the purpose of this and how electromagnetic radiations can be derived in mathematical way. Here in practical case, you can see it is what? It's a wire which is molded here. This is a complete dipole and this is a dipole which is having a feed point. These two are the feed point here, right? Similarly, the antennas which are actually many times one antenna is not enough to receive the signal, or we can say once it receives the signal, but the power which we require, it requires the series of antenna to connect together. That is called as an array of antennas. So when we connect the antennas in an array, it can be of any type. It can be of a array which is of, like here you can say it is a phase array antenna. These two antennas are there. This is dipole and this dipole. Same length of these two dipole at two different places, and the distance between this is also calculated and is kept. Why it is designed? There is a reason for everything. So when we discuss about this antenna, this distance between these two are kept based on the design, what are the impedance of the transmission line, and then it is calculated. And in between this, in the PCB, you can see these feed points are there from this antenna and feed point from this antenna. They both are taken together, and then through the coaxial cable point, it is connected to the either transmitter or receiver. Okay, so this is a phase array antenna. Another type of antenna which is wire antenna, but these antennas are in the loop structure. In the unit 1, you are going to discuss about the loop antenna also. It is the for educational purpose, you can say loop antenna. What is there? There is a wire from one point, it spirals, come back, there is a two loop inside, and then second end is taken as a second terminal of a transmission line. And the feed point is connected using the same coaxial cable. So this type of structure you can see, it is a loop antenna. So we'll also see what is the radiation pattern of a loop antenna. So in systematic way, one by one, we calculate the radiation pattern of antenna. In the next video to this, let me complete this. Next video to this, we are going to explain you one antenna radiation pattern, how we calculate radiation pattern from one antenna for this. And I think if you have any doubt, you are already connected with us, so you can follow us, or you can write us back in the WhatsApp group, or if you have any question, you can also write an email to us. Thank you very much. Thank you. It was going